everybody. Thanks so much for coming for my talk. So my name is Robert. I'm a software engineer at Google. I've been with Google for about 6 years. And today I'm going to tell you about Service Weaver. How many of you already know about Service Weaver? Or, okay, so not many, good. Have any of you guys already seen the talk or not? Okay, perfect. I guess otherwise we'll not be here. So, yeah, Service Weaver, it's an open source framework from Google for writing distributed applications. We've been working on Weaver for about 2 years, and we released it in March this year. And yeah, we are here to tell you about the framework. So, microservices have become popular, and I guess most of us, write microservice-based applications. If you look at this graph from Google Trends for the term microservices, you can see that the interest in microservices just went up. Also, we as a community develop a plethora of technologies to help grow the microservices ecosystem. For example, Docker and Kubernetes for easy and flexible deployment, service meshes like Istio for interconnecting microservices, CI/CD pipelines like Argo, Jenkins, Flux, whatever, OpenTelemetry, Prometheus, Jagger for tracing, for observability, and so on. So there is no doubt that microservices are very popular. However, it's unclear if they are universally good, and you should use it all the time when you write your applications. For example, if you go on the internet and you search microservices or like Monolith, you'll find countless numbers of articles, blog posts, videos on people arguing pro or against microservices. For example, we pick this random Reddit post and we look at some of the comments. Someone, for example, is saying that most people think a microservice-based architecture is a panacea, but it's not that simple because in the end it's a distributed system, and doing distributed systems is complicated. Another person believes that microservices are great, but we just do it in the wrong way because we are not drawing the boundaries between microservices correctly. Another person, just loves microservices just because they hate monoliths. While another person say that, microservices aren't bad, and people which say they are bad is just because they don't understand when to use them. While other person can't even tell, actually, if their project is a monolith or microservices. But it works, so it's good, and so on. Now, to make things even more complicated, if you look at the trends in industry, you can see that over time, companies like Uber, Etsy, eBay, Amazon argued that microservices are great, and they switched their monoliths to microservice-based applications. However, sometimes early this year, AWS published a blog post telling how basically migrating their microservice-based application to a monolith, they reduced cost by 90%. So there is no question that microservices are popular. However, the jury is still out there to answer the question whether they are universally good or not for your application. So based on our experience of writing applications and what we've seen also inside Google, we identified 3 main challenges which make writing distributed applications challenging. First, there is no official guidance on how to write your application. For example, should you write it as a monolith and keep the monolith as much as you can and only split later when you feel like you know what kind of we are doing and understand the behavior of your application? Or maybe you should just split into microservices and as many as you can and as soon as you can, because once you deploy, it will be very hard to change the boundaries. Second, we don't live in a clear black and off world where microservices or monoliths are good or bad. But they exist in a vast trade-off space where we have to trade off things like ease of development, ease of deployment, testing, and so on. And you as a user, when you write your application, you have to understand how your application, you have to understand these trade-offs, and you also have to understand what trade-offs are important for your application. So, to decide whether you want to use a monolith or a microservice-based architecture, which is extremely challenging when you design your application. And last but not least important, frankly speaking, the whole ecosystem is complicated. Clouds are complex, We have lots of technologies to learn, and once we get used to one of these, another one is released which claims it's even better. Also, when we develop our applications, we often are biased. For example, and we don't take into consideration technical reasons. So for example, if you see like Amazon, Uber, whatever, Google are doing microservices, we are saying, yeah, microservices are great and I should do microservices as well. Even if you don't really understand their use cases and why did migrate or they use microservices in their scenarios. And maybe my application is completely different and I don't have the same problems. So based on what we've seen inside Google, actually people are biased and they split. They split into microservices just because that's what they see everyone is doing. And what they end up is with an application with n different binaries, n different configs, all of them being rolled out on a different schedule, which is complicated. And finally, some people have used frameworks in the past and they had a bad experience, and now they believe that all the frameworks have like fundamental limitations, and they kind of try to avoid them, even if frameworks can solve some fundamental problems for them. And Corba is one example which always comes into place. So based on these findings, we came up with 3 core ideas how to address these challenges. First is we believe that when you write your application, you should write it as a modular binary, like a logical monolith, which is represented as a single binary. But at runtime, you deploy it as a set of microservices. In other words, basically decouple the logical and the physical boundaries of your application. So then, at runtime or later on while your application is running, you can easily change your physical topology. Second, we believe that you should delay the monolith versus microservices decisions for later, hence to minimize the need for trade-offs. We believe that you should start by just writing the application code because that's what you know best, what to write. And once you get enough experience running your application and understand how your application behaves, then you can take better decisions on what kind of architecture do you want to go with. And finally, we believe that you should focus on the application business logic and offload the complexities of cloud interactions to the runtime. We believe that we can take do much better opinionated choices with respect to the underlying technologies, what to use, than the user who has to reason about all this complicated trade-off matrix solution space. So we took these 3 ideas and we implemented them in a framework called Service Weaver, which is a framework for basically writing better microservice applications. So just to be clear here, we are not arguing that microservices are bad or you shouldn't do it, but we are saying you can write better and fewer microservices and then decide what you want to do next whenever you have enough experience what to do. So with Service Weaver, our goal is to make it for you easy to develop, easy to deploy, and easy to maintain high-performance applications which can run in any cloud and which significantly reduce cloud costs. So the rest of the talk, or the rest of the first part of the talk, will have 4 sections. We'll talk a little bit about how we develop application with Service Weaver. So a Service Weaver application is organized as a logical monolith, and you use only native programming language features to develop your application, and there is no code versioning concerns. Now, having this logical monolith, you deploy it as a single binary and a tiny config. However, the Service Weaver runtime will run it for you as a set of connected microservices which run on the same code version. And without any changes to your binary, you can run the same binary on your local machine, in any Kubernetes environment, or on a cluster of machines, and so on. The Service Weaver runtime is highly efficient. We have a lot of performance things done in the runtime. So we can significantly reduce your application latency and also significantly reduce your cloud costs. And finally, we have integrated metrics, logging, tracing, to make it easy for you to test, debug, and to understand the behavior of your application. So let's go a little bit into more details of how we actually achieve these things. So in terms of development, a Service Weaver application consists of a set of components that call each other, where a component is similar to an actor kind of like unit, for those familiar with the actor-based model. Under the hood, Service Weaver has a code generator to weavify the application. So basically, we generate encoding, decoding, stubs, registration, service discovery, everything for you. You write your application as a modular binary where your services are defined as simple Go interfaces. And then the Weaver will deploy it for you locally on the local machine on a single process or multiple processes, and distributed, multiple machines, pods, components being replicated, traffic load balanced, and so on. Now, let's look a little bit more into what is a developer experience of writing a Service Weaver application. So as I mentioned before, component is one of the key abstractions in Weaver. To define a component, you literally write a Go interface. So in this example, if you want to write a cache component, you just write a Go cache interface with a put method, and of course you can have other methods as well. Now, to implement a component, you implement it as a Go struct. The only difference is you have to add this Weaver.implements embedding, which lets the Weaver runtime to identify that this is a Weaver component and should generate the code accordingly. To instantiate, so for a Service Weaver application, you should always have like a main component, which has to explicitly be defined by the user. So in this case, app is the main component. And the way to let Weaver know this is the main component, you have the same embeddings Weaver implements, but now the type will be Weaver.main. And to get a reference from a component to another component, you can use a Weaver ref, and that's it. To run your application, in your main function, you have to run Weaver run, which takes like a function, which always takes like the main component. And then finally, in order to interact with the component, you just do simply method calls. In this case, you get from the app, the main component, you get a handle on the cache, and then you just do cache.put. So if you look at this code, it looks kind of very similar to the code you write, to run on your local machine, except these embeddings, which are needed by the Weaver runtime to run your application distributed. Now, you write the code like this, you release it as a single binary, and write a single tiny config. So the only thing you need in your config is the name of the binary. You can do simply go run, and you run your application in a single process. And one thing which we, as a team, Service Weaver time, find very powerful is like, you write your application, and you do a change in your application business logic, and just go run, and see the effect of that application, which is extremely powerful for debugging fast iterations. While today, with microservices, whenever you do a change to one of your services, you have to redeploy in the cloud, which takes maybe tens of minutes, and it's very, very annoying. Now, you can take the same binary, and you can do Weaver multi-deploy to run this application, the same binary in multiple processes. Or if you want to run it distributed, now you have to add a small per deployment config. So for example, if you want to run it on a cluster of machines, you just specify the location, the names of the names of the machines you want to run, and then same binary, no changes. You just do Weaver SSH deploy to run it in a cluster. If you want to run it in a vanilla, like any Kubernetes environment, you just specify this small config, and then Weaver kube deploy will generate all the YAML files for you, for all your Service Weaver application, and then you can simply do kubectl apply to deploy your application, or you can integrate this with your favorite pipeline. And finally, we have a custom GKE deployer. This is a very Google Cloud specific, which is a very, very powerful deployer because it allows you to deploy your application across regions. It does safe rollouts for you, has routing, can do custom resource management, everything. So the only thing you have to specify is the name of the regions and where your application should be available. And and again, you just run Weaver GKE deploy, and same application is running with this deployer. And let's say you are not happy with any of these deployers we provide, and we'll probably provide more. Then you can go to our website on the blog to the blog section. We have, like Michael wrote a nice blog about how to implement a Service Weaver deployer and what APIs you should implement, and you can do your own deployer for whatever you want. So let's look a little bit how actually the application is being deployed. So as I mentioned before, you just write a modular binary where you put your components in a logical monolith. Now the Weaver runtime by default will place each component in a different process. However, I didn't show, but in the config, you also have the option to specify collocation. For example, if you want to collocate some of these components in the same process. Then the Weaver will attach the Weaver libraries, which basically manage the interaction between the application and the runtime. And finally, the runtime, which can have different implementations, the ones you provide or the ones you can write. So in terms of performance, I mentioned before, like the service Weaver runtime is highly performant. We have our own custom encoding, decoding, which has no versioning overheads. We have our own custom transport built on top of TCP with custom load balancing. We provide collocation, which allows you flexibility to collocate some components. So for example, if you have two chatty components, you may want to put them in the same process so they communicate directly over method calls, and they bypass the network. Or if you have two components which you always want to be separate, you put them in separate collocation groups, maybe for security reasons. And finally, we provide routing support, which increases the likelihood to route requests to the same key to the same component replica. So this is very important, for example, if you want to add a cache, for performance reasons in your application, or if you want to build, like, in general, stateful services. So we did some benchmarking, and we took online boutique application from Google Cloud, which is an application advertised by Google Cloud folks. The application has 11 microservices. The only thing we did is we port all the microservices to Go, because we only support Go for now. And we test the microservices version of the app with the Weaver version of the app in GKE using our GKE deployer for a fixed QPS. So here I'm showing you the number of lines of Go code and the config code with Weaver and the microservices version of the app. You see there is a reduction in the number of Go code, and this is mostly because with Weaver you don't have to write encoding, decoding, protos, service discovery. You don't have to use any APIs to integrate to the cloud, nothing in your application. The difference is not that high here because of the nature of this application. But for example, more recently, we took another app called Bank of Anthos, also from Google Cloud. And when we ported to Weaver, the reduction in the lines of code is 40%. In terms of config code, there is no comparison because with microservice-based application, especially if you're running in Kubernetes, you have to write these YAML files. So in this case, for this application, I think we had like 1,500 lines of config, while with Weaver it's like 5 lines. Now, in terms of performance, here I'm showing you the number of CPUs used for this workload and the 99% latency with Weaver and the microservices version of the app. So yeah, the numbers just talk by themselves. And this is mostly because of all these kind of things we do in our runtime. Telemetry and testing. So Weaver, provides basically everything for you. Every component in Weaver comes with a logger, which is a wrapper around slog, which Jonathan will talk today at 11:15. The nice thing is, like, we collect all the logs for you, and then based on the deployer, you can export them wherever you want. And also we provide commands to manipulate and stuff like that. Metrics, we have our own metrics library. I will actually talk a little bit later more about it. We provide counters, gauges, and histograms. And we also generate frameworks metrics for you. For example, metrics which track, for example, the throughput, between components, like the request latency and stuff like that. For tracing, we rely on OpenTelemetry, and the only thing you have to do is you add this like hotel HTTP handler in your application, where we have a Weaver.instrument handler. I will show you a little bit later. And with a single line of code, basically, all HTTP requests and component method calls are automatically traced for you. And again, exported to the deployer, which decides to do whatever they want. And finally, we also use the Go profile package. And we have commands basically to capture the performance of your app as a whole. We just run, for example, Weaver GK profile, cache to get the CPU profile across all the components and component replicas across all the machines and everything in a single file. All right, so let me show you a little bit how to write a very simple service Weaver application and how we can run it in the cloud. This is the first time doing the demo, so hopefully it will go well. And then I will show you a little bit how we do the metrics in Weaver, and also a little bit the history of the core changes of our, the core API changes, and the lessons we learn, in case you are interested to see how we design our interfaces. All right, so let's see what's happening here. Okay, so what we will do, we'll write a simple app, which given a string, it reverses the string. So yeah, first of all, let's see, we create a simple like a module, and then what we do, let's see, let's create a main. No, let's create the reverser component. So as I mentioned in the talk, to define a component, you just literally define a Go struct. And then you define the methods you want on the component. In this case, we have this reverse method, which will take a context, and then it will take the string you want to reverse. And what will return is the reverse string and an error. So this is the definition. And the implementation, as I mentioned before, let's call it reverser impl. It's a Go struct. With the only difference is you have to add this weaver.implements embedding for the reverser. And then we have to write the implementation of the reverse the reverser method, which I'm not going to write it. I'll just copy paste because it's not like some Weaver thing. It's typical. So what we will do, sorry, just. Sorry, can you make it a bit bigger? The font, okay, sorry. Yeah, thank you. I will make it. Is this good? Okay. So that's how we define the component. This is how we implement it, and then this is where we implement the reverse method. So what we do with this is just, we take the string, we split it into runis, whatever, and then reverse it and return the reverse string. Okay, so this is how we define it. Let's do a go mod tidy. So we get the Weaver dependency. And now let's see how we use it. So in our main, we have to write the main function as well. So for that, as I mentioned before, you have to write a main component explicitly, and I'll tell you later actually why we reached to this conclusion. And to tell the Weaver that this is the main component, we have to add this Weaver main embedding. And then we want to get a reference to the reverse component as well. Let's call it R, and this will be weaver.ref reverser. Oh, sorry. Okay, yeah. Okay, so this is the main component, and now let's implement the main, where we instantiate a service Weaver application, and here we just do weaver.run and context dot. Let's pass a context, and then we pass a lambda, which takes and then, yeah, let's pass the lambda like this, and then let's say panic, or we do a log.fatal of error. Okay, and then let's define the body we want to run, which is, this is always, it has to take a reference to the main component. Okay, so we did that, and then we basically can reverse a string now. So we can do reversed. We do a dot. Okay, let me call this reverser so it's clear who is this. Dot get. So get is a generated method by Weaver by the Weaver generator to get the reference to the reverse component. And then you can just do reverse and call, and then let's say hello world. And then if we'll return an error. Otherwise, let's print it. Okay, reversed. All right, so let's do again go more tidy to get dependencies. And I will run Weaver generate. So Weaver generate, you have to run it whenever you add a new component or whenever you change the signature of the method, of the component, then you have to add it. And I think I have a problem here. Oh, here, thank you. Okay, you guys pay attention, which is great. All right, so I ran Weaver generate, and if you look here now, yeah, this is something which we generate for you. And we do all the kind of stuff, so you don't have to worry about it. But for example, here we do checks, for example, to check that there is no versioning mismatch when you run your stuff. Here we do register all the components, then we'll generate all the server and the client stuffs for you. And then we will do, here I think I think we generate this this auto-generated metrics, as I mentioned before. And then I'll show you also do encoding, decoding, you see, for example, here. This is basically our own custom encoding, decoding. We encode the things, we do the method calls, and then we decode things for you. And yeah, other things. Anyway, this is just for the curious. It's not something you want to throw. And then we simply do go run. And it reverses your hello world string. So this is simple hello world thing. Let's make it a little bit more complicated. Let's add a small a UI, so it's a front end. So for that, okay, I'll start to copy the code now because I don't want to spend time on this. But basically, we want to create. We will add a simple front end, index HTML page, which is not a Weaver thing. It's just some JavaScript and CSS. Oh, I can just copy paste, I guess. And then, yeah. So what we will do here, let me copy paste the code first. Okay. Maybe I shouldn't do that yet. So you saw that you can do the, you can simply call it from here, hello world. Now you can add a listener. So if you want to interact, with your application through a listener, which is the way usually you should interact with the service of your application. I didn't mention in the talk, but you can add a listener. And what you have to do is you have to export an endpoint on this listener. So basically, we'll have to do something like an HTTP server. Let's do this. So in your run, whenever, instead of calling things directly to print it, you will do it by exporting, starting an HTTP server. And then, okay. So now, this should be fine. Now if I do go run again, no, something I did wrong here. Oh, I didn't start the, sorry. I think I have to do, yeah, I have to listen on the listener. Okay. So now if you do go run again, I think I think I should print the address of the listener to see where it's listening. Okay, so by default, if you're a listener, you don't specify anything, it will listen on a random port. So it's good to print the address. Otherwise, in the config, I'll show you later. You can specify where your listener should be available directly. So here is now on 3.9. Okay, so there is no UI yet. So now we can simply do a curl. Localhost 39467, and I think the endpoint I exported was called reverse and the string. So basically reverse. So it works. Now we can also add the UI I mentioned. So for that we just have to export also the index/ So to do that, we'll do this. And I will have to add an embedding in order to, this is again, it's a Go thing, it's not a service viewer, but to basically put the content of this index.html into a variable. Okay, so we do that. And now, if you go again, and you do go run, okay, sorry. Okay, I have to do a go mode tidy again to call this. Oh, thank you. Yes. It's so nice to be among Go people because, they can tell me exactly what to do. Right, so now if you go to 38281, and you type stuff here, we just reverse stuff for you. Go for con. Okay, so what we did is, we create an app with a reverse component, and then we have a simple front end. Let's add, so all of this now when I run it, I run like the main component and the reverse component in the same process. So to see how that happens is basically if you run weaver single status, yeah. I think this is a bug, so discard that. But it's basically, you see here, like we have the main and the reverser component, and they all have the same PID, and because they run the same component. Let's run it actually in multiple processes on the local machine as well. So for that, we need to create a small config. And the config, as I mentioned before, it should have the name of the binary and a deployer section, as I will show you now. So name of the binary, you can run it in the, so we do this. And you can see here that what I do now is I also specify the address of the listener. I want to listen on port 9000, so it doesn't pick a random port anymore. So now, because I want to run the multiprocessor, I also have to build the application, like the binary. So I'll have to do build, go build. And then now if I do wither multi deploy config.toml, reverser, I think is because I need to specify the name of the listener. So by default, I could name this listener reverser, and it'll automatically map. Otherwise, I have to provide the custom name. So then, the weaver will be able to map the config for that listener with the actual listener. So be like this. So now, listener specified. What did I specify in the config? Am I high? Listeners.reverser. Oh. Okay. Oh. I think I will need to rerun the weaver generate because here we go. So now you run your application again. If you go to localhost 9000 now, again, you can write your hello world example. But now if you go to weaver multi-status, here you can see that, how do I increase the font of this one now? Command plus? Here? Custom fonts. Oh. Sorry. Right. So now you see like the multi-deployer basically takes every component and replicates it twice by default. And then all of the replicas are in different OS processes. So here you see for main, we have 2 replicas, different OS processes, and the reverser, 2 of them also different. Okay, so this is single process, then you took it run it in multiple processes. Let's quickly add some observability, and then we'll just run it in the cloud as well and see how it works. So for observability, we can do a simple thing. So for example, you want to log a message. What we can do is let's say you want to reverse something, the reverser component already comes to the logger. So just write debug reverse string, and then string. If you want to add a metrics, let's say you want to add a counter to count how many times you invoke the reverse method, then I think the only thing we have, the way to define the metric is dar metrics counter equal with metrics new counter, and then we call num calls and some description, blah, doesn't matter. So now what you can do is like we take this metrics counter and we log a message, and also we can do metrics counter dot increment. This will increment by 1, or you can add other things. That's how we added the metric as well. And let's add enable tracing as well. So to enable tracing, what we have to do is we can do the hotel HTTP handler trick, or we can do also, we can have our own custom mux where we pass a HTTP handler to a Weaver instrument handler, which returns another handler which basically trace all the HTTP requests for you. So what we do is we create, what is this, server.mux, or, no, I forgot what is the syntax of this, sorry. Yeah, it's HTTP servmux. Servmux. And then, yeah, we use our custom mux, and custom mux, and here instead of default we will pass our mux. And here what we'll have to do on the handle mux, we have to basically wrap the HTTP handler into a weaver.instrument handler func, where we pass a name, let's say reverser, which has to be a unique ID, and then that's it. And then the same is here for the other one. We do weaver.instrument handler func reverser, and then yeah, we embed this one. All right. So at this point, if I take now the same binary and I run it again, I would have logs with a multi-deployer at the terminal, metrics, and traces. So let's quickly visualize this. So okay, this is unreadable now. Okay. Sorry, now I'll have to go back here. Go for con. All right, so yeah, let's rebuild the binary. Actually, no, I think I have to run the Weaver generate again because I added some Weaver stuff. And then we rebuild it. And let's run it, multi-deploy config. Okay, so now if I go to localhost, again, 9000, and I type hello world, you see, now you have logs already. We also have a small dashboard actually for this multi-deployer. You can see here the application, and this is the version of the application running. And then here, yeah, you'll see some basic information, like the call graph. For example, we need two calls from main to reverser. The metrics is not something to be proud of. We don't have graphs yet, so it's like Prometheus format now. So we have to plug Prometheus. Sorry, yeah, Prometheus. And then for traces, actually, we integrate with Perfetto. And you can just go here, and you quickly see the traces for each component, which is pretty cool. Okay, so this is how we run stuff on the local machine. Let's actually deploy this in the cloud. So to deploy it in the cloud, where we are, okay, here. So to deploy it in the cloud, we will have to write in the config a small section for, let's say, our kube deployer. And this one, let me just copy paste the config here. So for the kube deployer, you just have to specify for your listener whether you want to be reachable from outside or not. So it can be an external listener. And then you have to specify basically the name of the image you want to, okay, I didn't copy it. The name of the image which you want to build. So what we do is basically we take your application and we create a Docker image, and then we will upload it to your Docker registry. Can be Docker Hub or be the whatever other ones. And then we will basically generate all the YAML files for you, and then you can deploy it as you want. So in this case, what I literally have to do, so yeah, that's my username for Docker Hub. That's where I will deploy it. Sorry, what I'm doing here. Okay, so now we have the application. If I do weaver kube deploy config, you can see here, we are basically building the Docker image. We upload the image to Docker Hub in this case, and then we will generate all the YAML files. So by default, we generate all the configurations for your application, and also we provide observability, integration of different observability frameworks. For example, Prometheus for metrics, Jagger for tracing, Grafana Loki for exporting logs, and Grafana for the dashboards. But you can also plug in your own. If you already have one of these running, you can plug it your own in the config. We have a section for that. Or we can do other ones. We do it for now, like this integration, but nothing stops us to do any kind of integration, or you can take this deployer and do your own. So if you look here now, we have this Kubernetes thing where we generate everything, which is something you don't even want to look at. But it's basically deployments, integration of horizontal pod autoscaler, create load balancer for the listener, and everything. So now if you do kubectl apply, I don't have any pipeline, CI/CD pipeline here, so I'll just do kubectl apply. We will basically deploy the application for you in the Google Cloud. I already have 3 nodes. Okay, I guess, oh, sorry, not this one, nodes. So we already have 3 nodes in GKE in the Google Cloud running. So we deploy it. And if I look at the services, no, kubectl, I think. Yeah, thank you. So you see, we are trying to get an external load balance, like an IP for your load balancer with your listener. And then in between, let's export Grafana so we can also see some dashboard. Literally, I added this dashboard and this Grafana integration before I came here, so it's still very rough, but it's still cool to see. So I'll just do a pour forward on the. All right, so, oh, I have to add a service, I think. Cool. And then hopefully we got the IP as well, so we can go, oh, yes, so if you pick this IP, if you go, bam. So we write hello world again here. And this is the one running actually in Kubernetes. Let's go to Grafana and see some stuff here, what's happening. So if you go to this port, first time we'll ask you for some, yeah, we don't want to set up any configurations. But, so what we do is by default, actually we export all the traces, metrics, and logs to Grafana. So if you look here, you have all these connections, data sources already for you, all set up. And this is because we launched these services for you, but even if they are launched, we'll automatically plug in for you with any of these combinations. So for example, if you go to Jagger here, I don't know, let's see, do we have a test? I think we should have some traces. Search, yeah, we have some trace. Look at the run query, we see what happens for our request, and you see something. We also provide some dashboard. Again, this is very rough. Service over runtime dashboard where you can see, for example, logs and also like the auto-generated metrics. We do it for you. For example, here you can see the method invocations. and method of errors, and then latency, distribution of latency for component execution, of number of bytes, and stuff like that. And here you can see the logs, again, for the things we do. So let's say I add another message, go for con. Yeah, things are changing. And we can do another thing as well. For example, let's roll out a new version of the application where now the reverser will just panic. We just kill it. Panic. Yeah, not panic. And the only thing we have to do is we have to rebuild the binary. And we'll redeploy, we'll regenerate the YAML files, and then we'll go to kubectl apply, and then we'll go now and see that things, yeah, actually, because we do automatic rollouts as well, rolling upgrades for you. Oh, wow, time flies. I think I'll not have time to talk about the second part. Right, so now if you launch the new version of the application, and let's say we go to where we are writing the reverser, and this thing should crash soon. I don't know when, but it should. I don't think I need to do Weaver generate. Anyways, I'm not. Anyway, yeah, maybe I should have done the Weaver generate. I don't want to spend more time, but basically this should crash, and then you should see the logs and stuff like that. Okay, let me stop the demo because I realize actually it's late. So one thing yeah, let me go back to the slides. So for the curious, I'll have 5 more minutes, so I'll go very fast on this. For the curious, we want to show you some use cases of Go, which we think is interesting for this audience in Service Weaver. So first of all, strongly typed metric labels. So, metrics are very important to understand the behavior of your application. However, most of the Go libraries which exist there, they let you represent the labels as key value pairs of some sort. So let's assume you have an application which serves some HTTP traffic, and a metric which makes sense for you is to count basically the number of HTTP requests to your application. So you write this HTTP request counter. Now you may want to add labels in order to dissect the measurements for your metric. For example, you want to add the path. So to understand for the request for which particular path was done. And also you want maybe to track the HTTP response status code. Now, if you want to do this metric with the Prometheus API, this is how you actually define the metric, where you see you specify the labels as strings, just strings. And now when you try to increment the metric, you have to pass this map from the label name to the label value, which are all strings. If you want to do the same thing with the OpenTelemetry API, this is basically how you define the same HTTP request metrics. Note that in this case, you don't even define the labels. And this is how you increment. You have to specify basically for every label the type you want to increment. So based on trying to play with these libraries, we identify several pitfalls. One, it's easy to misspell label names. For example, it's easy for you to write stats code instead of status code. And your metric is busted. It's easy to pass the wrong type for the label value. For example, before you saw you always pass strings, or sometimes can pass strings or ints. So maybe sometimes for the status codes you'll pass 404, or sometimes you can pass 404 not found as a string. Nothing prevents you to not do that. It's easy to misremember the labels because they are all over the place, and you have to update it all over the code. So, you don't remember. Maybe I said the path, and now, it was the path or the endpoint, which I had to increment. Also, you can have too many labels. Sometimes it's easy to add new labels, and everything will work fine, even if maybe some of these labels are not added to the metric. Or even if you remove some of these labels, some of these labels may still be active somewhere in the code because it's too much. Or you can, maybe forget to add some of these labels because they are not defined nicely with the metric. So in Weaver, we basically leverage the Go generics to create metrics where labels are Go structs. So with Weaver, when you define your metrics, you define like Go structs where the name and the type are explicit. And now to instantiate a metric, use the generics where you specify the metrics type label. And then to increment them, you always have to pass an instance of the labels. So yeah, this way. So in this way, defining metrics this way, for example, if you misspell the label name, the code will not compile because, this stats code or stats code doesn't exist. These are the name is explicit there. It's hard to pass a different type for the label value. Again, the code will not compile. You can't misremember because the types are defined very clearly in the Go struct. You can have too many labels. If you forgot to, if you add, you can't just randomly add a new label because it doesn't exist in the struct. And similarly, if you remove one label from the struct, your code will not compile unless you go all over the code and remove the usages of that label. And same as for too few labels. All right, so that was about the metrics, and this is a quick history of the main changes to the core API in Weaver, which I think it's very interesting. So this is a timeline of the main changes we did, before the release and after the release. You see, we still did some changes. Sorry, can I have two, 3 more minutes? Okay, cool. So in the beginning, this is the way we used to define the component, like an interface similar to today, and the struct. The only difference is we call the component an object, and also we had an explicit constructor, like a to-do, where to make the constructor explicit, we use a comment annotation. Weaver column object, and then the name of the object and the properties of the object. So this was what at the beginning. And then we realized that, actually the user doesn't have to specify the interface because, it's already from the implementation, we already can identify that and automatically generate it for the user. So then a few months later, we actually remove it. So the user doesn't have to write any interface. But then, almost a year later, we added it back. And this is the first lesson we learned. There is always a tension between precision and boilerplate. We don't want the user to write redundant code, but also you don't want to hide things from the user. So sometimes it's good to have things explicit. So for example, having an interface which the user can explicitly define and it's very nicely commented and formatted can be very useful, especially if you do some changes to your interface and see what's happening. Then this is the way you used to run a Weaver application. We use Weaver run at the beginning where you pass a function. And inside that function, for example, you can call objects. And we had that to get method for that. However, a few months later, we changed Weaver run to weaver.init because we felt like that API is more ergonomic, where the Weaver init returns you a handle on the main component. And then again, you can do whatever you want. However, in Go 1.18, the Go team introduced generics, Go generics. So then we replaced basically the get-to-do, which was a generated method to get the handle on the object, with the weaver.get. And then a few months later, we also renamed object to component because we felt object is too generic and it's hard to understand. We also were thinking about maybe to call it an actor or a grain or service or whatever. So one big effort for us started in September 2022 was about replacing the comments with constructor arguments. So when we added the comment annotations, we were inspired by other Go annotations, like for example, Go embed or generate. Go generate, I think. So we are thinking the comment is a good thing, but then we realized that it's very easy to mess up with this kind of API. For example, if you add a space between the slashes in the Weaver, then the Weaver generator will not parse this as a component, and your code is just failing silently. So what we basically started migrating the properties first in the constructor. Like, for example, the replicate became a Weaver.replicate property. And then we completely removed the comment and we replaced it with an explicit constructor where the constructor has to start with the Weaver make keyword. And this was a big improvement in the APIs. So the main lesson for us was try to avoid creating new mini languages because it's easy to do that. It's very easy to do that, but then it's very hard to extend it, in a programmatic way. So we think that you should rely on the existing languages and as much as you can, and only create new mini languages if needed, and even then be very careful of the changes you do. So while adding the explicit constructor with Weaver Make was a great improvement for us, and we got inspired because even in Go, you have naming conventions. For example, if you define symbols, it has to start with a capital letter, or if you have test, you have to be in an underscore test file, and so on. But even then, we found that this is easy to misspell, and then the Weaver generator will not identify this as a component. So then we replaced this with embedding, Weaver.implement, and this is what we have it today. And this is basically how you identify now a component. Okay, I'm going to go faster here because I'm over time. So the lesson we learn here, I think what we did also, this is more recent. Remember, like we have weaver.run, a function, and then weaver init, and then actually recently we switched back to weaver.run. And we switched weaver.run. And this is because we felt like the previous Weaver init gets a handle on the main component, but the user doesn't define the main component. It was kind of very confusing what exactly it is. So what we want to do is we wanted the user to explicitly define the main component, to basically understand like what is the flow of execution in their application. So that's how we end up with this design. So yeah, lesson here, which is maybe the most important one, the interface design is hard and requires a lot of iterations. For us, I mean, it's easy. I think the best is if you can look at, for example, like can associate like your problem with a particular like concept and try to use similar APIs, which people are using for that concept. For example, associative containers in C++. But for us, the problem was we were trying to basically interject remote communication interfaces in the middle of Go, and we didn't have such experience. So we tried all of these kind of approaches. But then based on the experience and when we faced different like situations, we felt like this API is much cleaner, and we will stick with it. All right, so one last thing here, we use Weaver get to get a handle on the component. However, this was also confusing because any component can do a reference to another component, and it was very hard for us to track the call graph, all the calls. And also, if one component was corrupted, for example, that can also call another component and corrupt that component as well. So what we did recently, we replaced Weaver get with Weaver ref, which have to be explicitly defined when you define your Go struct. So this allows us at compile time to build the whole call graph of our application. And this is useful, for example, to create a visual, like a call graph for all your application interactions. And also we use it for MTLS support. So in order to identify which components should only talk with each other and force secure out communication. So yeah, declaring things ahead of time can be powerful. I'm not going to go again over this. These are the main lessons you learn. So, and then the last topic was about how we detect stale code at compile time. But anyway, we have 3 blogs about these 3 topics. They are at serviceweaver.dev/blog, and you can find them all the details about it. I talk about Service Weaver, what it is. I'm not going to repeat again. This is a website. We are looking to contribute, give feedback. We want to work together to understand what we should do next for you to adopt it. And if you didn't get tired for this hour, we have a workshop after lunch in Queen Vault at 1:30, where you guys can actually try to write a emoji search engine. So this I conclude my talk, and I'm sorry I'm a little bit late.